allowed a blinky car to move across a flat surface, and we decided we wanted to be able to describe the motion of the blinky car. So, in order to describe the motion of the blinky car, we decided to collect some information. We decided to make the independent variable clock reading, which we knew would have to go on the x-axis of our graph, and we collected that in beats of a metronome for most people. Some groups use flashes of a car. For our dependent variable, we measured the position. Where was the car at each beat of the metronome? The dependent variable belongs on the y-axis. So when we went about building our position versus time graph, again, the independent variable clock reading was measured in seconds. We could have used the symbol for clock reading, which is t for time. Position went on the y-axis. It was measured in centimeters. Instead of using the name position, we could have used the symbol for position, which is an x with a vector over the top of it. Again, clock reading, the symbol is t. It tells us when, and it's a moment in time, an instant in time. It can be measured in seconds, hours, or other units of time. Position, the symbol for position is an x with a vector over it. It tells us where something is, or the location of an item or an object. It can be measured in meters or centimeters, or other measurements of distance. Generally speaking, our graphs had this shape. Students noticed that the slope of the graph was constant. They also figured out that the slope of the graph represented the speed of the blinky car. Furthermore, we've decided that the fact that the slope was constant told us we had a constant speed. However, they also noticed that the slope was a positive slope. So it not only tells us the speed, but also the direction the blinky car was moving. A positive slope would suggest a positive direction. A negative slope would suggest a negative direction. Speed has a symbol, just the letter V. It tells us how fast is something going. You can calculate speed by looking the distance traveled over a period of time. If someone were to want to calculate the average speed over a time period, they could use average speed, and the symbol is just a V, and it's got a bar above it called a vinculum, which just means the average speed. When scientists, physicists specifically, know the speed and the direction of an object, it now gets a special phrase, and that, or a new term called velocity. And that is the speed and direction of an object. If you know the velocity at one moment, the symbol would just be a V with a vector over the top of it. But if we know the average speed, it would be, if you know the average velocity, it would be the vector over the V and a bar for the average. And that, again, it tells us how fast and in what direction the object is moving. To find out more about where the car started, we need to take a look at this part of the graph. That part of the graph is called the y-intercept. Now, for any y versus x graph, the part of the graph where the line crosses the y-axis, so right here, is the y-intercept. And it always tells us the y value when the x value equals, well, what would the x value be right here? That would be when the x value equals 0. So how do we make that specific to our position versus time graph? Well, if it's the y value when the x value is 0, this y-intercept, the y value would represent a position when the x value is 0. So the position when the clock reading or time equals 0. In other words, the position at time 0 would be the starting position. When you're looking at a position versus time graph. So, in summary, for a position versus time graph, the y-intercept represents the starting position, or you could use the symbol, the position when time equals 0. And the slope of the graph represents the speed and direction, or you could call that average velocity of the object. Now, what if instead of having 2 batteries in a car, you only had 1 battery in the car? Well, you would still have a starting position of 0. It could still move in a positive direction, but if it was moving in a positive direction but at a slower constant speed, you might expect a graph to look